17. This is video part 2. We're going to erase this. I don't know who put this up here, but he was an idiot. So the guy you got talking now is way smarter. Okay, so what we're going to do with this is we're going to notice first this -1. And whenever I have a -1 exponent, what that allows me to do is I can drop everything below a division bar. Okay? So what I end up with is x minus y times the fraction 1 over. And then I'm going to drop each of these things with negative exponents below its own division bar. So this becomes x over y plus y over x down here. And this is over 1. So the simplified fractional form of this is x minus y over x over y plus y over x. So we're not quite done with it, because what we're going to do, let's see. With this part, we are going to do like what the other guy showed, which is simplify this bottom fraction by getting common denominators. So this is going to get multiplied by x over x. This is going to get multiplied by y over y. So we have x minus y over x squared plus y squared all over xy. And how I want to look at this from here is x minus y divided by a fraction. Well, I can't divide by a fraction, so I'll end up multiplying by its reciprocal, right? So let's see, I want to drag this down here a little bit. Okay, so I have x minus y over 1 times the reciprocal. Okay, so I'm multiplying by xy over x squared plus y squared. And really that's all they kind of do with it, is they put this outside and they show it like this, where this is our final answer. So I think that's a lot more doable. Does that make sense? Does that make more sense than, than earlier? So you definitely want to tell people to watch part 2 on that. Okay. Let's see, that was number 17, so we're ready for 18. Draw a reference triangle and evaluate. So we've got radical 3 tan 60 plus radical 2 cosine 45. These are in degrees. Minus 2 radical 3 tangent 30. Okay, so the first thing on all 3 of these is to get reference triangles drawn up on coordinate planes. And we want to make a habit of that, because later on they're going to give us degrees that all don't automatically put us in the first quadrant, and so we need to be able to, be flexible. So this first one, 60 degrees. Let's pick a different color so we can see that a little bit better. Okay, so 60, 30, 90. What goes opposite of 30? In a reference triangle, in a 30, 60, 90 triangle, what goes opposite of 30? No. 1. 1, 2, radical 3, right? So what is the hypotenuse? No. Goes in order from least to greatest. So 2, radical 3. So at some point we need to memorize that opposite of 30 is 1, opposite of 60 is radical 2, opposite of 90 is 2. Sorry, radical 3, opposite of 60. Okay, so let's come over to this other one. This is 45 degrees, 45, 45, 90. What's opposite the 45s? 1. So 1 and 1, and opposite the hypotenuse, or opposite the right angle, or on the hypotenuse? Radical 2. Okay, and then we've got 30, 60, 90 over here. So 30, 60, 90. What's opposite of 30? 1. What's the hypotenuse? No. 2. Radical 3. See, here's the thing, is that radical 3 is actually smaller than 2. 2 is bigger, because radical 3 is actually like 1.71, something to that effect. All right, so we've got radical 3, and and we're going to write it as radical 3 over 1 times tangent of 60. So what we're looking for is a ratio. Okay, so tangent is what? Opposite over adjacent. So we're always finding opposite of the reference angle over adjacent to the reference angle. So what's opposite of 60? Okay, and what's adjacent? 1. So I get radical 3 over 1 times radical 3 over 1. So we get 3, yes. All right, now I'm going to bring down that plus. I'm going to put it right here. Okay, now we have radical 2. We're going to go ahead and put it over 1 times cosine of 45. Cosine is adjacent over hypotenuse. So what is the adjacent? No, adjacent. What's adjacent to the 45-degree reference angle? 1. What's hypotenuse? Radical 2. So I get radical 2 times 1 over 1 times radical 2, or radical 2 over radical 2, which is what's anything over itself? 1. So right now I have 3 plus 1. Okay? Now this has a minus, so let's go ahead and bring that down. We're going to say 2 radical 3 over 1 times tangent of 30. So tangent is what? All right, what is opposite of my reference angle here? 1. What is adjacent? Radical 3. We're getting it, but it's going to just come with practice and repetition. So I've got 2 radical 3 times 1 over 1 times radical 3, or 2 radical 3 over radical 3. What happens to those radical 3's? They cancel out, and I'm left with what? Or just 2, right? So I got 3 plus 1, just 4, minus 2. So my final answer is 2. Okay, and this was question 18. Double check my answer. 2 is correct. Doable? Great. All right. After 18 is 19. 19, a sphere has a volume of 2,304 cubic miles. Find the surface area. All right, so the volume of a sphere is equal to what formula? Got to know it. We had to know it earlier. 4 over 3 pi r cubed. Good. Now, what are we replacing v with in this question? (2,304 pi). Okay, and that's equal to 4/3 pi r cubed. What we want to do with this is we want to solve for r so that we can plug it into the surface area formula. Can anybody tell me what the surface area formula for a sphere is? What is surface area? No, it's not using 4/3. It does use 4 pi r there. All right, so we need the r from this to be able to plug it in there and get our surface area. So my pi's will cancel out because I'm going to divide by pi on both sides, right? So what I want to do is I need to get to 4/3 over. Normally I would divide by 4/3, but in this case I have to do what? Multiply by 3/4. So I need 2,304 times 0.75 if that's easier to do in your calculator. $1,700 and what? 28. So I got 1728 equals r cubed. Cube root 1728. What's it come out to? Do we know how to cube root in our calculator? No. You can't just put a 3 in front. So you hit math, and you go down to number 4, and then hit the 1728. Okay, so we get 12. 12 equals r. Now, we're not done. We come back over here to this equation, and we type in 4 pi 12 squared. But we would just want our answer in terms of pi. I know 12 squared is 144. I want 144 times 4. So I get 576 pi, and this is in miles, and it's surface area, so it's squared. Okay? Not terribly difficult. Pi's cancel out. Yep. All right, number 20. How much water should be added to 414 ounces of a 21% alcohol solution to get an 18% alcohol solution? So with this, we want to consider that we have a percent of something times an amount at that percent. Okay? So what they start out with is you have a 21% alcohol solution, and a percent is going to be written as a decimal first. All right? And we have a certain amount of that. We have 414 ounces of it. Okay? Of is multiplication in math, so that stays pretty easy. Okay? And we want to add water to it. Okay? So many ounces of water. Well, water isn't a percent solution. Okay? It's just X. Okay? But we want it to equal something. We want it to equal a certain percent. We want it to equal 18%. But a percent is always times an amount. We already have 414 ounces, and we're going to add X to it. Okay? All right. So the rest of this, if I've done this right, hopefully I have. All right, okay. I think the only thing I might have, because this is technically a 0% solution, because water doesn't have any alcohol, right? So it kind of cancels itself out to a certain extent. Does that make sense? All right, so first off, we're going to multiply 0.21 times 414. 86.94. And we're going to distribute the 0.18 to 74.52 plus 0.18x. Okay. Subtract. Okay. All right, what do you get there? Get 12.42 equals 0.18x. Divide by 0.18. Okay. What is 7.42 divided by 0.18? All right, and I believe our answer is in ounces. So water should be 69 ounces. That's what we want to add to it to dilute it down to an 18% solution. So it's a real practical question. Okay. All right, we need 1. The sum of the digits of a 2-digit counting number is 11. So we want, A plus B equals 11, or better yet, the tens digits plus the ones digits equals 11. So things that add up to 11. Okay? Well, if it's just going to be a 2-digit number, it can't be like 10 and 1. That would be 3 digits. All right, so yeah, because anything, you don't get anything till there. So 3 and 8, let's go ahead and get all of them together. 3 and 8, 4 and 7, 5 and 6, right? You said 2 and 9, so we need to come back up there and slide in 2 and 9, okay, just so we've got them all in order. Okay, now anything else would flip it around. So read the rest of the question. It says, when the digits are reversed, the new number is 9 more. So we want the smallest numbers on the left. Okay, we want the original number to be small. We want the new number to be big. And it says when a number is reversed, the new number, the big number, is 9 more than the original. So these have to be numbers that are fairly close if they only have a difference of 9. So usually when the numbers are really close, you're looking at things a little towards the middle, right? Because at this point, it would switch over to 6 and 5. So 65 minus 56 would equal 9, right? So the original number is 56. Does that make sense? Okay. We probably didn't have too much problem with that one. Okay, I know there's a handful of people got it wrong. Let's look at 5. All right, we got f of x equals x squared minus 2x plus 3. Okay, it says evaluate. A, it wants to know what f of 2 is. Okay, so all we do there is we do 2 squared minus 2 times 2 plus 3. So 2 squared is 4, minus 4, those 4's cancel out, and I'm left with 3, right? Okay, let's see, it also has a b, so it wants negative 3, right? So that's negative 3 squared minus 2 times negative 3 plus 3. So I get 9 plus 6 plus 3. So I should get 18. So I should get 3 and 18 on that. Does that work for you guys? Okay. After 5 is 3, which would be really confusing for people watching this video later. Like, how on earth is 5 or is 3 ever after 5? All right. 3. 3 had an A and B. Okay. So gives you the absolute value of x plus 1 is less than 2. So I have to solve it twice. X plus 1 is less than 2. X plus 1 is greater than negative 2. Have to switch the signs and change the sign of the solution, and then solve. So minus 1, x is less than 1. Minus 1, x is greater than negative 3. So then graph it. Okay, I got 0, I got 1, I got negative 1, negative 2, negative 3. I got open circles on both ends. And x is less than 1, but it's greater than negative 3. So I'm in between there. Okay, negative 3 and 1. On B, we've got the absolute value of x plus 1 is greater than 2. So a little bit different. Okay, still solve it twice. X plus 1 is greater than 2, but x plus 1 is less than negative 2. All right, subtract 1, x is greater than 1. Subtract 1, x is less than negative 3. Okay, still got 0, still got 1, still got negative 3. There's still open circles on either end, but x is less than negative 3, so it's got to go back to the left from negative 3. But it's greater than 1, so it's got to go to the right of 1. Does that work? Okay. What was this? 5? Oh, was that 3? 3, yep, 3. So we're ready for 12. Might be able to get most of this done. Let's see, when you guys are out of here at what, 51? I don't even know anymore. No, yeah, you eat in 7th hour on early outs. I think you eat in here at like 11:50 to 12:14 every day. Okay, so there's probably lunch coming soon. 12. How's it going? I'm going to go ahead and grab mine and then keep teaching. Thank you, sir. Yeah, you should be able to just plug it into your graphing calculator. Now, here's what I want you to do with that, is I want you to list me a table of values. All right, so you should just get that. Okay. So give me a table of x and y values to go with your graph. Ethan, are you eating? 13. All right. So to determine a function Okay, to determine if something is a function, it has to pass the vertical line test. I think we understand what that is, right? Okay, but the second part of this is determine if it's one-to-one. Now, it's only a one-to-one function if it is first a function. So if it doesn't pass the vertical line test, we don't care if it's one-to-one, right? We don't even list anything. It's automatically not a, I mean, it says one-to-one function. So if it doesn't pass the vertical line test, it's not one-to-one. But in order to be one-to-one, it has to first pass the vertical line test and then pass the horizontal line test. Okay? So for instance, something that doesn't pass, something that's a function but isn't one-to-one, would probably look like that. It passes the vertical line test here, which makes it a function, but it fails the horizontal line test. Okay? So that's an example of a non-one-to-one function. So you should look at A. A passes both. It passes the vertical and horizontal. B passes the vertical, but notice that it has multiple lines, so it's not passing the horizontal. Okay? C passes both. And D is in the same circumstance as B. It is a function, but it's not one-to-one. Okay? So you'd have to look at this sheet of paper to get all that, but all right, I'm going to try to keep going here too. Which of the following sets of ordered pairs are functions? So when you're looking at question 2, you're checking your x's in all those coordinates. If any of those x's repeat, it's not a function. So notice on A, it goes 8, 12, 3, 5. 8, 12, 3, 5. So it's going to be a function because all the x's are different. B has 3, 6, 3, 5. And then if I look, I've got 2 3s, and the y's on both those 3s are different. So the answer is no on B. C has 1, 2, 3, 3. And then, so it repeats 3 twice, and the y's are different. So C is also not a function. And D goes 5, 6, 7, 6. Okay? And then whenever I look at the 6's, it has a 7 and a 5 for the y's. So they're different. So automatically no. Does that make sense on 2? No, it's just yes, no, no, no. All right, that's all I need. Okay? It's really easy one to get right. It's also really easy to get wrong. Okay? Let's see, I need 10. Factor 3x to the 6n plus 2 minus 6x to the 7n plus 1. So there is a shorter way than expanding it all out. That is first to look and see just what goes into everything. So there's a 3 in both constant terms, right? And then I want to look at the one with the fewest number of n's. The x with the fewest number of n's. Well, that's 6, right? That means I can take 6 n's out of both sets. And then I want to look at the one with the fewest number of just straight x's. The first one has 2 just normal x's, and the second one only has 1. So I can only take 1 out of each of them. Does that make sense? Okay. Then I have to put inside something that's going to allow me to multiply the outside number by the inside number to get my original. So 3 times what equals 3? 1. All right. Now I've got x to the 6n. I don't need another n, right? But I do need another x so that I can get x to the second. All right. So if you wanted to write it as 1x to the first, just so that you know where everything is going, all right, 3x to the 6n plus 1 times x would get me 3x to the 6n plus 2. Correct? All right, now I need to get 3x to the 6n plus 1 to multiply by something to get negative 6 x to the 7n plus 1. So 3 times what equals negative 6? Negative 2. And x to the 6n times what would equal x to the 7n? X to the 6n times what would equal x to the 7n? Okay, you're close. I can't have just an n. It's x to the n. Okay? X to the n. Because that's x to the 1n, so x to the 6n times x to the 1n, or n, is going to be x to the 7n. So that's going to be 2x to the n. And notice that I already have that 1 out over here, so I don't need to put any kind of 1 or number with it. Now, would you rather see that in expanded form? I mean, that shows a lot less work, but you have to understand what's going on. Okay? So I know, like I talked to another student, they preferred to see the expansion because they can, match pieces up and then just see flat out what's left over.
I don't have the expansion also, I don't remember that.
Okay, good. All right, the statement was that this individual, who will be unnamed, Jocelyn Perez, understands the expansion well enough that if they don't remember how to do it the simplified way, they could do that. All right. Now they know. Now they know. All right, let's see. Where are we at? That was question number... That was 10? Yep, 11. 11 again, that's just a simple plug it in your calculator, get the graph, give me a table. Y equals 3 to the x. You get something like exponential increase, and you're going to list a table of values, okay, to go with it. Okay, it's that easy. You can give me a little bit of extra work. Okay, but your calculator is going to do all that for you. All right, last question, and we're going to call it finite, number 16. All right, so this one, we've seen a lot of this on our homework, right? We made mention of this just the other day when it showed up, and it seems like it was maybe even the exact same question. I don't know. What's that? On this? No, I don't think you can because they're squared. No, I don't think that you can do a matrix on these. But it's honestly fairly simple. Granted, what you have here is a circle and a hyperbole, so there should be 4 answers. The one that we had in our homework, though, only had 2 answers, and the reason why is because when we graph it, that hyperbole came out and only touched the circle at 2 spots. That's the minimum. I mean, maybe not the minimum, but that's how you only get 2. Normally, we'd see a situation where we'd get something like this, a little bit more like a baseball, and we'd get 1, 2, 3, 4. 4 is certainly the max number of solutions we can get, okay? But as I look at this, right, we're just trying to solve for a variable. So if I add the 2 equations, I can cancel out the y's. And x squared plus x squared is 2x squared. There's a fly that just hit my smartboard and caused like a giant line. Yeah, no, seriously, that happened. All right, and 4 plus 2 is 6. Divide by 2, x squared equals 3. Square root. So x equals positive or negative square root of 3. Let me see here, we're on 16. Yeah. All right, and then after this, what we're going to do is we're going to plug that in back up into an original equation. So square root of 3 squared plus y squared equals 4. Okay, square root of 3 squared is 3. 3 plus y squared is 4. Subtract 3. Y squared equals 1. Square root both sides. Y equals positive or negative 1. Okay, which gets me 4 available solutions. Should be anyway. Let me come back to my answer here. Yeah, so I've got a positive radical 3 to go with a positive 1. I've got a negative radical 3 to go with a negative 1. I got a positive radical 3 to go with a negative 1. And a negative radical 3 to go with a positive 1. There should just basically be every combination of x's and y's available there. Questions on 16? How frustrated would you be if the sound was still off? Probably very. Okay, so I think that's every question. I think there was like one question there that everybody told me not to do. I don't know if it was what? The proof. All right, we'll leave it alone. What? Yeah, it's given, vertical angles are congruent, side angle side, congruency postulate is it. They're way easier than the ones in geometry. All right, I'm going to stop it right there and get this out to you. Way